Hi everyone, I'm Gyuri from South Korea. It was a long trip, yeah. Until last month, I was working in a fintech industry, building applications for credit, loans, and investment like finance. But recently, I joined a new company called Bobby Talk, a platform for plastic surgery. And when I told my friends, their reactions were pretty funny. Oh, I didn't know you were interested in that domain. Oh, have you? And I said no. And then, will you? Oh, I said no. But you know, it got me thinking. In cosmetic surgery, people start with good intentions, yet sometimes side effects appear unexpectedly. And honestly, that's exactly what happens in our code bases too. So we start with good intentions, just adding one small features, one tiny function. But before we know it, the side effects spread everywhere. So today, let's talk about side effects, not the kind that need a doctor, but the kind that needs an architect. So every single application has them, and one of the most overlooked yet universal side effects is logging. We all analyze something through logging, and I've seen many developers treat it as something easy, even trivial. But here's what I want to say. Logging is the perfect example of side effects. It looks simple, but when it is left unmanaged, it spreads quietly across your code base and starts shaping your architecture in invisible ways. It's not part of the UI, it's not part of the business logic, but it touches both, it lives everywhere. Logs are like gossip in your code base, they travel everywhere, but nobody really owns them. And of course, you're already logging every screen view, every button click, every tiny interaction. And as mobile developers, logging feels like part of the must-do checklist. But let me ask you this, how dimensional is that data inside your code base? Is it structured? Is it contextual? Or is it reusable? Or is this just fragments scattered all over the place? To explore this, let's look at two cases. Let me start with a concrete situation. Suppose you want to know how much of the content the user actually scrolled down. On the left, you log almost every pixel of movement. Nobody will do like this because that would be absurd. But on the right side, you log meaningful thresholds like 25%, 50%, or 100%. And logging isn't just about capturing random moments. It should be intentional, deliberate, and designed. The real insight doesn't come from raw events, it comes from designed events. Logging everything is noise, but logging meaningful is signal. Here's another case. You have a linear flow with, let's say, 100 screens. On the first screen, users can pick one of the three options, option 1, 2, or 3. And that single choice defines the rest of their journey. And now imagine this, every screen after that, screen 2, 3, all the way to screen 100, needs to load every event with the parameter selected option. It looks fine, totally harmless, but this tiny piece of logic, passing data for logging, can quietly grow into something much bigger. So here's what it looks like on the first screen. It's the source of selected option, and the user picks one, and we simply pass it to the next screen so that we can log it there later. Looks fine for now, but then the second screen has to pass it again, and the third and the fourth, all the way down to screen 100. The final screen. And every screen now needs to accept selected option, carry it down, and sprinkle it into log event function. The thing is, most of those screens don't even need this data. They are just passing it alone only because logging demands it. Now imagine this. We add another parameter like selected another option, which is triggered from screen 2. And it needs to influence every following screen from screen 3 all the way to screen 100. And suddenly, every path, every loop, every transition has to be aware of two separate contexts. And the more follows like this you add, the faster the complexity explodes. Now, some might say, why not just send the values you want to log to the server and let it reconstruct later? Sure, it's possible and way more simple, unless it's a single case and independent data from any other user interaction and logics. Otherwise, this means every meaningful click will cause an API call. So the server can't be always magic key. If we just throw all meaningful data to the server, they might be meaningless data at the end. We saw the scroll event example. We think scroll behavior is meaningful, but saving all movements of users' movement wouldn't give us insights. When the backend has to join massive data sets with delayed insights and a huge cost, it could be inefficient way. That's why client-side logging is not optional but essential. We are not just data producers, we are the developers closest to the user. If we want to truly understand the behavior, we have to capture the context right here on the client. And we have to do it responsibly, not spamming APIs, not trying logs to fragile UI, but designing them with structure. Early in my career, my approach to logging was basically post-its. I sprinkled a log event function here and there, past QA, shift the feature, and move on. When I had to reuse some events, I didn't overthink it. I just made an event, a num, reusable event, ABC, something like that. And it felt a bit tidier, but honestly, nothing had changed because it was still scattered, still fragile, still unstructured. Post-its don't make a diary. Then came the breaking point. One day, I had to inject the same set of parameters into over 100 random events. In the code base, those events were completely independent, but from the data side, they were connected. Together, they represented a single user flow, a flow that the code didn't understand, but the analytics demanded. I had to make hundreds of these log lines, dozens of files scattered everywhere, just to track one simple flow. And it looked fine until someone said, hey, we need one more parameter. Like this. Suddenly, every single log needed to carry an extra parameter. It was a nightmare, and not just because of the repetitive work, but because any small mistake could cause unexpected side effects. QA became harder, regression risk went up. And that's when it had hit me. I had applied the single responsibility principle only to code structure, but never to user behavior. Events are meant to represent behavior, and behavior deserves its own architecture. Each of these logs were just raw data, isolated, repetitive, and unaware of each other. They told me what happened, but never why or how it connected. I realized my logging had no structure, no narrative, just fragments scattered across the code base. Then it clicked, single responsibility principle, SRP, shouldn't stop at code. It should extend to user behavior. Events that share the same intent belong together, and that's grouping, like this. And in code, that grouping takes shape as objects. Once I modeled behaviors as objects, scattered logs turned into structured stories. Now, before we jump into real examples, let me tell you what I want you to take away from this talk. First, the technical problem that appear when logging is ignored, and second, why logging should live outside of UI and business logic, and third, how to design the separation so it scales. And finally, that isn't really about logging, and the same principles apply to every side effects like networking, caching, right, refreshing token, anything. And logging is just the lens. The real lesson is about structure. So first, the simplest way is just calling log event function directly inside the view. It works and it's quick, and we've all done it. In this checkout view, each button calls log event function with its own level. It works fine until the UI changes. Maybe the buttons get combined or replaced with a segmented control. Suddenly, every log has to be retested because logging depends on the exact shape of the UI instead of the real intent. QA can be confident, and automated testing is nearly impossible. But the business question was the same. Which payment method did the user choose? But logging was tied to specific UI buttons. A redesign erased or changed the logs, and there's no structure guarantee that analytics still matches the business intent. Another common approach is passing the analytics instance everywhere. It feels systematic at first, but imagine screen 1 captures a piece of data and suddenly screen 100 needs it too. Now 98 screens in between and are forced to carry parameters they don't care about. And the structure collapses under the weight of irrelevant arguments. One new piece of data forces updates to every downstream screen's initializer. So probe drilling explodes and maintainability dies. Another shortcut is putting analytics into an environment object. Now it's accessible anywhere in the tree, but well, the problem is it hides the dependency. You can't tell from the code which view is logging what. And in a big project, it's impossible to reason about, and code reviews miss critical side effects. And if someone forgets to attach it at the root, the application can be crashed. So I think most of us have done this at some point. You add an if statement or a state variable, not for the UI, but just to make sure a log fires correctly. It works and it's fine, but little by little, your UI logic starts to shape itself around analytics. Branches, alerts, and extra states appear only for logging. At that point, you can't really see your logging anymore. It's buried inside the interface, another invisible side effect. There are many ways to log, but without a structure, they become scattered. When flows break, context is lost. A/B test data is hard to piece back together. And in code review, these hidden logs are easy to miss. No structure means no reuse and no guarantees. But what if the logger remembered where the user came from? What if it held states across multiple screens? What if we model it instead of sprinkle it everywhere? Up to now, logging has been something we sprinkle here and there, no memory, no context, or no structure. But imagine flipping that. Instead of a throwaway call, the logger could know where the user came from and hold on to that journey and actually model the flow. That's a completely different way of thinking about side effects, treating them as part of the architecture, not an afterthought. Think about it like this. When a user taps a button, that's an event. But the meaning of that tap often depends on what happened before it. Without context, logging becomes flat. We lose the narrative of the user intent. And how can we design a logger that understands flow? This might sound like overkill at first, but once I tried it, it actually made my code simpler, not more complex. And it led me to one of the Swift's UI tools, which is Actor. Let's talk about those next. Before we tame side effects, let's align on the basis of Swift concurrency. I will keep it this quick because you already know async await. But I want to highlight the concepts that matter when we talk about side effects. And the Swift concurrency model is built on structured concurrency that tasks have clear lifetimes, no more detached threads. Isolation through actors and sendable types guaranteed state is safe. Async await makes flows explicit, so you don't lose context in callbacks. Now let's talk about the actors. An actor is like a class, but with one big difference: it protects its own state. Only one task at a time can access its mutable properties set. That means no more race conditions and no manual logs, no hidden data corruption. You can think of an actor as a safe little box around your data. Multiple tasks can send messages to it, but inside, everything happens in order. That isolation is the key. Actors give us a narrative way to model stateful parts of your application without worrying about concurrency bugs. If you call increment from multiple tasks, Swift guarantees that only one runs at a time. You don't have to think about logs or queues. The actor enforces safety for you. And this might look simple, but it's very, very powerful because now we have a tool that not only helps with concurrency, but also gives us a way to assign ownership. So the concurrency is about ownership, but so at the first glance, actors seem simple. They isolate state and they keep our data safe. But honestly, when I first learned about them, I wasn't sure where they would actually fit in my code. And in practice, I wasn't sure when to actually use one, and it wasn't until I fought with logging and analytics spread across my project that I realized an actor could own that responsibility. That's when it stopped being abstract and started being practical. Concurrency is actually about ownership. Who owns the work? Who owns the state the work touches? Actors aren't just about preventing race conditions, they're about ownership. An actor says, this piece of state belongs here and only here, and that makes it not only safe, but a clear boundary of responsibility. One place, one owner, one story. An actor gave me one central place to hold state across the user journey. Every view model or screen could look safely, asynchronously, without worrying about threading. I didn't know to pass context through navigation anymore. The actor already knew it. And that made the logs consistent, context-aware, and way easier to reason about. And the best part is here. It's straightforward to test and mock because it's just one component with a clear boundary. Just a quick recap. We've seen how logging is scattered, fragile, and easy to lose context. So let's make that problem explicit as requirements. We need one central owner, so logs aren't scattered. We need UI independence, so redesigns don't break them. And we need flow awareness, so we capture the journey, not just flat events. And we need testability, so logs can be verified without touching the UI. That's the problem definition, and the solution I will show is designed to meet these needs. Before we dive in, I want to clarify one thing, and this isn't the only answer. There are many solutions, and it's just one possible approach. The actual implementation can differ depending on your architecture and the kind of user behavior you want to analyze, or how your data team structures their analytics pipeline. And also, optimization and security absolutely matter. But for now, I'll skip those details to focus on the direction, making logging flow-aware, well separated, and testable. And the key idea is here, events deserve their own layer, a design made only for them. So let's take a quick look at the high-level structure. This diagram shows how the core pieces, the logger, event groups, and sinks work together. We'll have three moving parts. First, a flow logger, which is an actor that owns the flow context. It's responsible for holding states like which option did the user choose or what AV group are they in. And second, event groups, which represent behavior context. These are objects that encapsulate user intent, not UI. And finally, sinks, which are plugin layer, so that decide where the log actually goes, maybe Firebase, maybe OS log, maybe your own analytics systems. But the important part here is the UI doesn't assemble any parameters. It just tells an intent, and the logger takes care of the context. Let's start with the core protocol. This is the event group, the smallest behavior unit. It represents a user context, not just a screen. Inside the event group, value represents the context, the meaningful state or situation you want to capture. It's what describes why the user is doing something. And the parameters, on the other hand, are the raw data, the actual key value pairs that get logged and sent out. And this method to parameter is what connects the two. It transforms context into raw analytics data. In short, value is what we understand, and parameters are what we record. And update is how the state changes when an event occurs. By itself, this doesn't log anything. It just describes how to transform behavior into data. This small abstraction lets us isolate what to log from how to send or where to send. And notice this isn't a class or struct, it's a protocol. So that's because we don't want to log this to one implementation, like one specific case. Each event type can define its own behavior, but all share the same interface. This abstraction gives flexibility. We can extend, swap, or test without touching the rest of the system. And event groups model what happens, the behavior, and things define where it goes, the destination. By abstracting this behind the protocol as well, we separate the semantics of events from the mechanics of delivery. This makes the system extensible and add a new sync without touching existing code, and testable since you can swap real output for a mug. Depending on your environment, you can swap things freely, like console for debugging, OS log for production maybe, and testing for verification or unit test. So logging itself becomes controllable and not scattered. Now the flow logger is where everything connects. It's an actor, which means it guarantees isolation. Perfect for current updates from multiple async flows. It keeps a list of event groups, a global context like device or information, and a list of things. Also, I mentioned at the first, the specific implementation can be changed, depends on your system, and it keeps these fields. And when you call log, it gathers all context from attached event groups and merges everything and fans out to all things. Let's look at some concrete event groups. The first one is selected option group, like this. And it implements event group, so it remembers what the user picked on screen 1. You can assign option value through the update function, and you can implement the specific raw data feature or data format into the two-parameter function. And the second example is experiment group, like A/B testing or something. It knows which experiment bucket the user belongs to, and when attached to the flow logger, every event automatically includes selected option like this, and any global fields or any fields that are related to the experiment or A/B testing, things like that. And no proof drillings and no UI pollutions are here. No matter where and what you want to log, you can simply inject a flow logger event group and use it. Each part of the application logs through the same structured channel, but with context-aware behavior. The logger layer stands on its own and completely separated from UI or business logic. And once I saw this working for logging, and I realized the same pattern fits a lot of other cases. Analytics pipelines or metrics collections, A/B testing, and some kind of experiments or shared state across the application, and even user session management like refreshing token. And if anywhere I need a sync-safe state that spans across the whole app, an actor can take ownership, because I said before, the concurrency is about ownership. So I started to treat actors less like concurrency utilities and more like side effects managers. They don't just hold data, they own a responsibility. That clear boundary makes effects like logging, analytics, or even A/B testing easier to mock in tests and way more predictable than when they were scattered across my code. The big takeaway is here, side effects are part of your application's behavior. Actors give us a way to model them as behavior, not accidents. Logging was just my entry point, but other cases and a lot more fit into the same pattern. Thanks for your attention. And if you'd like to leave a question, please scan the QR code. I will show it again.